Fire protection in aircraft. Fire protection systems are installed on aircraft to detect and protect against an outbreak of fire. You will find this system in near the engine compartment in the fuselage to protect the occupants. This system monitor the condition which could lead to a fire and are comprised of smoke detector, heat sensor, near engine or hydraulic system, and visible and audible warning in the cockpit. The chance of a fire in a small general aviation or experimental type aircraft is very remote, but at least the engine compartment should have some form of detection, as in the area where heat and air and contaminable fluid are together in close proximity.
Good day to everyone. Today we're going to discuss about the thermal switch system.
Thermal switch fire detection system. These detectors are normally suitable at points most likely to be affected by fire, such as an engine breathing outlet or hot air ducting. The type of most commonly used is a switch, the contact of which are actuated by the differential exposure of the similar metals. The thermal switch is unit type and called a spot or point detector. A thermal switch fire detection system is a circuit in which one or more thermal switch are connected in an electrical circuit, which also has a warning light and an oral alarm to warn the flight crew that an overheat condition exists in a particular area. If more than one thermal switch is on circuit, the switches are connected in parallel. This makes sure that if any switch closes, a warning is given. In some circuits, the detectors are connected between two wiring loops. Thermal switch system. A number of detector or sensing devices are available. Many old model aircraft still operating have some type of thermal switch system or thermocouple system. A thermal switch system has one or more lights energized by the aircraft power system and thermal switch that control operation of lights. These switches are heat-sensitive units that complete electrical circuit at a certain temperature. They are connected in parallel with each other but in series with the indicator's light. If the temperature rises above the set level in any one section of the circuit, the terminal switch closes, completing the light circuit to indicate a fire or overheat condition.
They are often used in power supply to protect the event of an overload. They can also be used on a thermostat in a certain heating and cooling system. Normally, closed thermal switch that the contact of thermal switch normally remain closed. When temperature increase to the set value, the contact should open and cut the circuit off.
As the switch begins to increase in temperature, the bimetal heats up until it reaches the temperature where it deflects and thereby opens the electrical contacts. When the temperature decreases, the bimetal returns to its original shape and closes the electrical contacts. Another type of thermal switch is a PTC, or rather known as positive temperature coefficient thermistor. These thermistors have a switch temperature at which the resistance suddenly rises rapidly, limiting the current through the circuit. When used in conjunction with a thermistor relay, the PTC will switch off an electrical system at a desired temperature.
No one set number of thermal switch is required. That is usually determined by the aircraft manufacturer. Once some installation of the thermal detector are connected to the light. On others, there may be one thermal switch for each indicator light.